Okay, guys, so welcome back to my YouTube channel. So today we'll be looking at a question on demand estimation. Okay, I think it was part of an assignment. Okay, most of you might have seen it, so it wouldn't be new. But we'll see how we'll approach this in case you haven't tried your hands on it, and probably also get to see how you treat certain parts. Okay, without wasting much time, let's dive right in. Okay, so the question says that Papa's Pizza has been in the pizza business for a while. Though it has a large customer base, it seeks to be a market leader in the pizza market by increasing its customer base. This will mean that the firm has to set a price that focuses on maximizing its sales than to maximize profit. To help the firm decide on its pricing decisions, it engaged the services of a research firm to estimate the demand for pizza. From a market survey conducted by the research firm, the estimated demand equation is the equation is Q subscript X equals 240 minus 2px plus 0.4pz plus 0.08y. So beneath it is the corresponding standard error. Okay. Then we have the R squared. Okay. All right. So it continues to say where Y is disposable income of consumers, PX price of Papa's Pizza, PZ is price of Eddie's Pizza. That is a related commodity. The value in parentheses are the respective standard error. So yes, that is that. So consumers' current disposable income is 1,000 cedis and the price of Eddie's Pizza is 100 cedis. Okay. All right. So that is that. We already have the information. So we just have to go through the V, and VI. So without wasting time, let's dive right in. Okay, so the first part is to interpret the coefficient of the independent variables. So to do that, if you've watched my previous video on demand estimation, you would know how to go about this. If you haven't watched it, then probably you have to go back and watch that video. Okay. All right. So to be able to interpret it, this is how you do it. So before let's make it official. This is for Puppet's Pizza, right? So Puppet's Pizza, okay? So that we make it official. And we have the I to be interpret the coefficient. So before we interpret the coefficients, let's write the equation down. So it's Qx equals what? 240 minus 2px plus 0.4 pz plus 0.08y. Okay, with a corresponding standard error of 0.669. Then we have 0.68. Then we have 0.1. Then we have 0.025. Okay. So each standard error corresponds to its independent variable. Okay. Okay. So we don't need the R squared here. So let's go ahead to interpret. So this is how you go about it. So you first quote the first one, which is px. Okay. So ps is 2. Then you start. Uh, unit change in px, okay, will lead to a change in qx, okay, by, then you bring the amount, okay, by 2 units, okay, in the opposite direction, or things being equal. So like I explained earlier, because this is 2 units, which is a negative, it's to the opposite direction. In the situation where it is a positive, it is to the same direction, okay? So here is a positive. So when you interpret this, it is to the same direction. This side too is also the same. So the same direction, okay? So we'll do same for all of it. So I'll fast forward it. So this is the interpretation you're going to give it. Okay, let me adjust it. Okay, so bear with me. So this is the interpretation I'm going to give it. Okay. All right. So that's for the I. So we are done. We move to the II. So let me use a red pen here. So red pen. Okay. So it says that what is or are the significant determinants of quantity demanded, and we should explain. So we can say I normally write the question so that anytime that I'm making reference, I know that this is how the question was formed and that is how the answer goes. Okay. So that is why I write the question before answering. But then in examination setting, you can just go straight, okay, because we need the answers, not the question. All right. So to do that, if you watch my previous video, I was talking about in the case where they do not give you the the significant value, okay, you use the rule of thumb. Okay, so in this question over here, they only gave us a demand function with no significant value. Okay, but they are telling us to determine the significance of this equation. Okay, so we use the rule of thumb, and the rule of thumb is what is 2. Do you get it? So then we have to first quote the our formulas. Then we look at the decision rule. Okay, then we'll see whether the equation fits or not. Then we'll see whether they are all significant. I mean, the answers are significant or not. Let's look at it. Okay. All right. So to do that, we say we need 2 things. So we need um T cal. So T calculated. which is tcal. Okay, and the formula for tcal is what? Is coefficient or parameters. So it's either coefficient or parameters. So if you see coefficient or parameters, is basically the same. All over standard error. Okay. So this is for tcal. Then we are using a rule of thumb. Okay. We call it the critical value. Okay. So critical value, which is the rule of thumb. So we call it T tab. Okay. So T tab. So T tab equals what? 2. Okay. So after that, then you come and draw your decision. So now we have what we are going to use, the T calculated and the T tab. Okay. So then you come and draw your decision rule. So you write decision rule. Okay. So colon. Then you say if, okay, I hope you're seeing. So if tcal. So if tcal is greater than what? The T tab. Okay. Meaning the coefficient is significant. Okay. Then you come. But if what? The same thing, tcal is less than what? The T tab. Then it means, so meaning, I don't know if I wrote it well. So meaning that the coefficient is what? Not significant. I don't know if I had the spelling right. Yes, not significant. So this is our decision rule. So we are saying that if tcal is greater, okay, than the T tab, then meaning the coefficient is significant. Then whatever that we are working with, okay, over here. So these are the coefficients. So whatever that we are working with, this coefficient, this one, okay, the -2, 0.04, and 0.08. Okay, so we are saying that if we calculate it using the tcal, okay, and it is greater than the T tab, then it is significant. Okay, but if it is less, then it is significant. Basically, that's what we are looking at. Okay. All right. So now that we have it, let's draw our table. Okay. So to do that, the first part is the variables. So variables. So for the variables, we have what? Px, Pz, and y. So there are only 3 variables. And we have the parameters or coefficients. So parameters. So the parameters, you put in the values, the coefficients. Okay, I don't want to go back. So we have what? -2, 0.4, and we have 0.08. Okay. So we have the standard error. So the corresponding standard error is 0.68, 0.1, and 0.025. Then we have the tcal. Okay, so let's do the tcal together. So the tcal, we said what? It is the coefficient divided by the standard error. So the first coefficient 0.2 divided by the standard error is 0.68. So we have 2.94. Okay, so 2.94. So here we don't need a negative, so you maintain the 2.94. Okay, then we do for the next one. So 0.4 divided by 0.1, and the answer is 4. Then we have 0.08 divided by 0.025, and this gives us what? 3.2. So then we bring our t-tab. Okay, the t-tab is constant, so it is 2, 2. So now here comes our decision. So you write here decision. Okay, decision. So we are saying that according to the decision that we made, we are saying that if tcal is greater than 2, then what does it mean? Then it means that the coefficient is what? Significant, right? So here it is 2.94, which is greater than 2. Okay, so that means it's significant, right? This is 4, which is also significant. This is 3, okay, which is greater than these 2, so it's also significant. So now that you are done to explain, you say conclusion. Okay, so the conclusion is that all the variables, so we have px, pz, and y are significant. Okay, so the conclusion is that all the variables px, pz, and y are significant to the model. Okay, they are all significant. So that is it. Okay, and let's put it in the question format, in the way that the question was framed. So it says that what is or are the significant determinants of quantity demanded. So we can frame this to be said that all the variables px, pz, and y are significant determinant, okay, of quantity demanded. Okay, so as simple as that. All right, so that is how you go about it. Then let's go to the III. The III says that we should what? State the law of demand and explain how the estimated demand equation confirms or rejects the law of demand. Okay, so that is the III. So we should state, we already know or have an idea of the law of demand. So what does the law of demand says? So the law of demand states that as price increases, shit. Supposed to use blue pen. Well, I've already used this. So the law of demand states that as price increases, quantity demanded what? Decreases. Okay. So the law of demand states that as price increases, quantity demanded decreases, and vice versa. Okay. Okay. So the law of demand states that as price increases, quantity demanded decreases, whereas quantity demanded increases when price decreases, all things being equal. Yeah. I think I didn't frame it well, but that is the notion. Okay. So saying that as the law of demand actually says that where price increases, quantity demand decreases, and where price decreases, what quantity demand increases. Okay, so that is the whole notion. I think I didn't write it well, but you understand it, right? So put it in a nice way, okay, so that you get marks for it. Okay, so that is the whole idea. So the question states that explain how the estimated demand equation confirms or rejects the law of demand. So this is it. Let me show you something real quick here. Now, we use the linear function, okay, to mostly determine our demand or supply. So mostly when we get a demand function like this, let me use alphabet. So A minus BX, okay. Now, mostly demand function is what? Inversely related to price. So QD is inversely related to price, okay? So what this means is that this sign over here with demand function must always be negative, which means that as price is going up, quantity demand comes down, okay? So they are inversely related. Do you get it? Now, in the case of supply, so we have QS, okay, which equals A plus BX, okay. So in the case of supply, what we say is that um quantity supplied, okay, is positively related towards price. So what we mean by positively related is that as price increases, as price goes up, quantity supply also goes up, okay? So as price goes up, quantity supply also goes up. So that is what we mean by it being positively related, and with the demand function it being inversely related, okay? So take note of this. It's very important. It's going to help you in certain cases like this. So then back to the question. So the question says that we should what? Um Explain how the estimated demand equation confirms or rejects the law of demand. So already we know the demand equation, okay? So that is QS equals 240 minus 2PX and all that stuff. So then the answer will be, so this time let me use a blue pen, give a space. So you start by saying from the demand function, okay, from the demand function. So you can put into bracket Qx equals what? 240 minus 2px plus 0.4 plus 0.08y, bracket close. So you can say that what? From the demand function, p, the the coefficient into bracket 0.2 of px, okay, of px. So confirms what? The law of demand. It confirms the law of demand, indicating, okay, indicating that as price increases, okay, the quantity demand, okay, quantity demand, quantity demanded. So as price increases, the quantity demanded, okay, of, so PS is what? Of PX or Papa's Pizza. Let's use Papa's Pizza. So of, because we've used PX here, so let's use Papa's Pizza. PS is the same as Papa's Pizza. So of Papa's Pizza what? So as the price increases, the quantity demand of Papa's Pizza also what? Decreases. Decreases. Holding other factors constant. I hope I wrote it well. So from the demand function, so you put this one there, the coefficient, which is negative 0.2 of px, okay, which is price of Papa's Pizza, okay, confirms the law of demand, indicating that as price increases, the quantity demanded of Papa's Pizza, okay, decreases, holding other factors constant. So that is how you interpret it, okay, in the case you come across a question like this. All right, so now let's move to the next question. So the next question states that what? It state the law of demand. Explain how estimated demand equation confirms or rejects the law of demand. So yes, so this confirms the law. So then we are good to go. So we should find an expression. The next question: find an expression for quantity demanded in terms of price. Okay, so let's use the red. If they tell you to find an expression of QoS in terms of price, they are just trying to say you should make QoS the function, okay, whereas price is part of the variable or is an independent variable, a major independent variable. Yes, that's how best I can explain it. So you should make Q the quantity demand of this, okay, the function, okay, of the equation, okay, making price the major independent variable or the significant factor in the equation, okay. All right, so now that we have that in place, let's find an expression for it. So already we have the demand function to be Qx equals, so let me see. So the question says here Qx equals what? 240 minus 2px plus 0.4 pz plus 0.0 y. Okay, so now that we have this, let me adjust that. So the next thing is we'll go back to the question and substitute all the variables, the values we had for each of these variables. Okay, so 240 minus 2px plus, so 0.4. So in the question, pz, which is Eddie's pizza, was what, 100, right? So 100 plus 0.08. In the question, disposable income was what, 1000. So 1000. So that's it over there. So at this stage, let's compute. So 240 minus 2px plus, so 0.4 times 100, okay, will give us 40. So this side is 40. Then plus, we come back to 0.08 times 1000, which gives us 80. Okay, so this is a figure. This is the only different odd item here. So this and these are all figures. So let's add this. We add this and this, we get what? 120. So 120 plus 240. Let's put them together. So answer is 80 plus 40 plus 240, right? That gives us what? 360. Okay. So 360 minus 2px. So that is all that we are looking for. Okay. So now we've been able to express Q in terms of price, and price is px. Okay. So here price has become the major variable, the major independent variable in this equation. So we've expressed qx in terms of price. Okay, so that is what it's all about. I hope you understand that. Okay, so that is that for Ivan. Then we come to what? Vin. So Vin says that we should what? Using the new demand equation. So yes, so this has become the new demand equation. Okay, so let me write it here. So using the new demand equation in Ivan, which is this one, find the price and quantity that will maximize the firm sales revenue. So using the like I said, I want to write the question so that whenever I go back to looking at the answers, it becomes easier. I see that this was the question that led to this answer. You get it? Uh-huh. I don't just write the answer and then later when you go back, in case there is no question, you wouldn't know what you were doing over there. You just wrote the answer there. Okay. It's just for reference sake. Okay. All right. So that is it. So the question says that what um we should use the equation. So this new demand equation, qx equals what? 360 minus 2px. We should use this equation, okay, to find the price and quantity that will maximize this firm sales revenue. Okay. So if the question comes in this form, they are talking about revenue. Okay. This is what you should take note. So when you see revenue, okay, you should think about the profit function. Okay. You know the profit function has to get profit is what? Total revenue minus total cost, right? Uh-huh. So if the equation is talking about maximizing revenue, not in the case of elasticity, no, don't think about that. This is a case where we are looking at maximizing revenue using what? Price and quantity. Okay, so if the question talks about that, then the first thing that should come in mind is what? TR, which is total revenue, which equals what? P times Q. So the question is saying that we should use the new demand function to what? To find the price and quantity that will maximize what? The firm's sales revenue. So to do that, we already have Q, okay, because we made Q an expression of P, okay. So in literal sense, this is what it means. So making Q, okay, 3602P. Okay. So this is what it literally means. So making Q an expression of P. Do you get it? An expression. So we finding the expression for Q in the term in terms of P. This is what it's it's talking about. Okay, so I wrote it like this so that we'll be able to fit it in the total revenue function to be able to find our Q and P. Okay, all right, so then we further put this function into this. So it's going to be P, open bracket, then we bring the function 360 minus 2P. Okay, so P times Q. So the Q has already, we've already found it. So the Q is here. So this is our Q. So P times Q. So this is the whole of Q. So now you multiply through by P, you're going to get 360P minus what? 2P squared. Okay, so this is what you're going to get. So this is our total revenue. Okay. All right. Now that we've gotten this, now we have to find P, okay, to enable us to find Q. Do you get it? Already, this is a Q function. So we have to find P to enable us to find what? Q. So to do that, we have to differentiate. Okay. So we'll delta, so it is going to be delta TR, which is for this, all over what? Delta P. So because you are going to differentiate P, so P comes here, which equals, now if you differentiate 360, what are you going to get? You get 3, the same 360, right? Now if you differentiate negative 2P squared, so it's going to be, so 2 times 2 gives us what? So negative 2 to 4, right? So it's going to be negative P. So we subtract 1 from here, which gives us what? Negative P. So now that we've gotten this, our works become simpler. We then equate. So we write where delta TR equals delta TR over P equals 0. So in the case our equation equals 0, it will imply that 0 equals 360 minus 4P. Okay, so then we group like terms. So P comes to the other side. So this is negative 4P. We jump it over the equal to sign. It becomes what? 4P equals what? 360. Then we want P to stand alone. So we divide both sides by 4, right? So divide both sides by 4. So 4 cancel itself, 1 cancel here, 1. So it's left with P over here. So we're going to get P equals what? 360 over 4. Now we want we have to simplify this. So let's use the calculator. So we say what? 360 divided by 4. That is 90. So P equals 90. Okay. So now that we've gotten P, we put P, sorry, we put P back into this Q function to get Q. So put P equals 90. Okay, this one into Q function. Okay, that is going to be Q equals 360 minus 2P. So 360 minus 2 open brackets 90. Now, P is 90. Okay, so 360 minus 2 times 90 gives us what? 180. Okay, for trust issues, let us confirm. So 2 times 90, so it's 180 as I said. So 180. Then 180 you less 360. Okay, you are going to get 180. So which means that, so this means that, or we can say therefore our price, so therefore the price and quantity, my handwriting, quantity that will maximize the firm's sales revenue are. So price and quantity, right? So price is Ghana cedi 90 and 180 units respectively. Okay, so that is how you go about that. Okay, so we are done with the 5, the V. Okay, now the last part is labor experts. So that is VI. We say that what labor expects employers to increase income, that is disposable income, by 20% in the next year. How would the increase in consumers' disposable income affect the quantity demanded? So you can say to be able to solve that, let's bring our equation in on board. So it's QX equals what? 240 minus 2px plus 0.4 pz plus 0.08 y. Okay, so now this is our initial equation, okay? And they are saying that what happens if employers increases their disposable income by 20%? Okay, so what it means is that we are supposed to increase the disposable income by what? 20%. Okay, so to do that, we repeat this one. But over here, the 2px, okay, we found it and we realized that 2px was what's 90 cedis according to the previous question that we answered. So we put that in. So is 90 here plus 0.4. Now in the question, PZ was given to us as what? 100, right? So 100 plus 0.08. Now, y has to be increased by what? 20%. So to do that, you would have to multiply the disposable income, which is 1,000 by 20%. Okay. The answer that you get, you add it to the 1,000 itself. Okay. So plus 1,000. This is how it's going to be. So let me put this into a small bracket. Then this becomes a bigger bracket. Okay. So you multiply 20% by the 1,000. The answer that you get, you add it to the 1,000 itself. That will show the increase. Now the 20% that I'm multiplying over here is showing the percentage increase, that 20% in the 1,000, and that's what is going to give us. Then you add it to the 1,000 itself. That will show the increase. Okay. So let's put everything together. So this is 240. So negative 2 times 90 will give us what? 180, right? So plus this will give us what? 40, right? Okay. So plus, let's maintain our 0.08 and let's work with the bracket first. So 20% times 1,000 will give us what? 200. Okay. So plus the 1,000. There's 1,000 here. So that would be like 1,200. So let's simplify that. So it's going to be 240 minus 180 plus 40 plus. Now let's multiply this 0.08 by the 1,200 here. Okay. When you add this and this, you get 1,200. So let's multiply it, or just punch everything in there. So 1,200 plus 1,000, right? You're going to get what? 96. Okay. So that's the answer you're going to get. You see that? And let's confirm. So 1,200 times 0.08. Yes. All right. So now that we've gotten that, we just sum everything up to see our QX. Okay. So it's 240 minus 180 plus 40 plus what? 96. Okay. That gives us 196. So then 196. So what is happening here is that when there is a 20% increase in income, then quantity demand is also going to what? Also going to increase. Okay. It's also going to increase by this amount, 196. Do you get it? So how did I know it's going to increase? Because here the coefficient is positive, which means PX is a normal good. Okay, which is Puppet Pizza is a normal good. So if it's a normal good, then a 20% increase in income will also increase what? The quantity demand by this amount. Okay, so that is it. So then you can write, therefore, let me put it here. So therefore, 20% increase in income or disposable income, okay, in income will lead to an increase in quantity demanded by what? 196 units. Okay, full stop, finish. So an increase, a 20% increase in income will lead to an increase in quantity demanded by 196 units. Finish. So that is the end of this question. Okay, so I assume that if you get anything similar to this, you do justice to it. Okay, all right, so until then, we meet again. Bye bye.